Greetings and welcome, friends. Mr. Waddy here. We were talking about like volumes of prisms and cylinders yesterday. Lauren, be quiet. So the volume of either is the area of the base multiplied by the height. In this particular prism, Malik, what type of prism would this be called? No. It's a trapezoidal prism, so the base is going to be the non-rectangular shape. So that is the base. If you guys don't recall, the area of a trapezoid is equal to half the height times the sum of the bases, Lauren. And so now I can find that area. I guess I could call this just capital B as well in our case, right? So if I want to find that area, that is going to be half the height, 1.8, times the sum of the bases, 1.2 plus 2.3, and that would give me the area. And then I would multiply this through, and imagine like each of these trapezoidal shapes being the pages of a book. As I multiply it through, it's right adding volume to it, and that would give me the volume of the entire figure, like so. So let's see, I guess I could calculate this for you. I actually brought my calculator home yesterday. Doing some calculating. 0.9 times 3.5. So the area of the base is 3.15 for the area of our trapezoidal shape. And so therefore the volume, this by the way would be measured in centimeters squared. And so the volume is going to be 3.115 multiplied by the 2. Here, can you stop the clicking? Double it. And I'm going to get, no, what? What? Wait, what? Did I? Was that 3.115? Okay. I must have not had the correct second answer in there. 6.23. Centimeters cubed. And that's literally answering the question, how many tiny cubes that are a centimeter by a centimeter could fit within this space, although some of those cubes you would have to slice up and rearrange. By the way, the old Finnish grandmothers called mumus used to have sugar cubes with their coffee that are probably about a centimeter by a centimeter. And the thing that they used to do is hold it in their upper lip against their tooth and drink their coffee black, so they wouldn't put the sugar in the coffee, but as the coffee would pass through their mouth, it would get dissolve that sugar cube slowly over time, and it would add the sugar to the coffee. And also, that's why Finnish grandmothers frequently had one rotten black tooth. So not the recommended procedure for how you sugar your coffee. Here we go. Here's a cylinder. Now, yeah, Tyler, this is funky. What is going on with this? What? Can I even find the volume of this, Joshua? Oh, what do I need? Okay. Yeah, so I could use cosine. Yep. Absolutely, I could find the height. I could find the height saying that cosine of 30 degrees would equal the height over 18, because the height is the adjacent to that 30-degree angle. You could have also done sine of 60 would equal h over 18. I also just, knowing the ratios for 30, 60, 90, 18 divided by 2 is 9 will give me the shortest leg from the hypotenuse, and then multiply by the square root of 3. Either way, I would end up getting height is equal to 9 square roots of 3. Now, does it matter for calculating volume, the fact that this is like a crooked, oblique cylinder? No, it does not. It appears as though this is a 12-meter diameter, so the radius is going to be half of that, which is 6. So I think the volume will equal the area of the base, which happens to be a circle. So I'll use pi r squared, so pi times 6 squared, multiplied by the height, which is now 9 square roots of 3. And I'm going to get 36 times 9. I feel like that's definitely something I should know. 324. Nope, I don't feel like I should know that anymore. 324 pi square roots of 3. By the way, in terms of leaving these as exact, these are in meters cubed, exact values with pi and the radical non-decimally approximated. The radical goes last, primarily because if I wrote it as 324 times the square root of 3 pi, someone might overextend their vinculum on this square root symbol, and then you would have to question whether or not the pi or the 324, if it was written over here, was underneath the square root or not. So typically a square root will go at the end of your number. You could also then get a decimal approximation for that. So 324 times pi multiplied by the square root of 3. Here we go. And I got 1,763.01 meters cubed. Those are meters. What? This thing is giant. Maybe. Alright, this one's a pain. But I figured I'd do it for us here. So, for a hexagonon. No, it doesn't matter. Words are just things made up by people. I'm going to need to find the apothem. This length is 2 for that side length. By the way, I'm jumping the gun here. This is a hexagonal prism, and just because it's sideways doesn't mean the hexagon is not your base. Alright? Right. So here is 2. This entire angle is 60 degrees. This would be 30 degrees. Therefore, this is 1. It's half of 2. And multiplied by the square root of 3 and a 30, 60, 90. 1 square roots of 3. You could have also used cosine and all of its friends or whatever. Tangent actually would be the one I would have used to figure that out. So the apothem height is, the apothem is the square root of 3, which is about 1.73. So I know the volume, and I'm looking for the height of this hexagonal prism. So the volume is going to equal the area of the base, which is half the apothem times perimeter, right? And then multiply that base times the height of the prism. So let's plug in what I know and solve for what I don't. So I'm going to have 72.66 is equal to, fortunately this is in inches cubed and this is in inches, verify that my units are working with the same dimension, even if one is cubed and one is linear. So a half the apothem is the square root of 3 multiplied by the perimeter. There is 2 times 6, so that the perimeter is 12, multiplied by h. So that's going to be 6 rad 3h, right, is equal to 72.66. How could I solve that equation for h? Yeah, whatever that thing is. And I'm going to get h is approximately 72.66 divided by 6 times the square root of 3. Oh, did I not put enough parentheses around that? I'm going to... No, it was fine. I got a 6.99 inch... right there. Okay, so with these volume formulas, you don't only get to use them to calculate the volume when you know all of the linear dimensions. You can also know the volume and find a corresponding linear dimension. Let's see, was that the last? No, we had a composite volume, didn't we? Ooh, look at this. All right. So what type of shapes are these? Solids? It's a... It looks like it's a rectangular prism. Right? So I'm going to find the volume of the big one, minus the volume of the skinny one. Man, this drawing is getting worse and worse by the minute. And that's going to equal the leftovers. Right, Joshua? So, volume of the big one is going to be the area of the base multiplied by the height, which notice the height is not, it's oblique, it's crooked. So the 5 is going to be the thing that's helpful for us. So I'm going to do, the volume of this guy is going to be 4 times 2 times 5. Those are all in feet. No, I'm getting, no, yes, no. So this is 40. The volume of this is 1 by 1. So this is going to be 1 times 1. The height of this, what's the height of this one? Still 5. So this is 5, and then I subtract those. I'm going to get 35 cubic feet as the remaining volume. So volume addition postulate, the little volume plus the little volume equals the big volume. And then similarly, I can subtract to make that happen. Yes? Yes. Yeah, so a composite is just like the combination of multiple volumes. This one is like a subtraction of volumes, a difference. But yeah, Isaiah, thoughts? Yeah, we'll talk about that later, I think. All right, thanks for watching, Internet friends. Have a great day.